All right, we're going to take a look at the first step of aerobic respiration, glycolysis. All right, now recall that this is the first step regardless if oxygen is present or not. Okay, so no matter what your scenario is, you're going to begin with glycolysis. So here we have a cell, and we have already looked at the process by which the sugar gets inside the cell. So here we have our glucose. And glycolysis literally means glucose breaking. So what's going to happen is one of the first things is the input of a little bit of ATP. Okay, so we're going to use 2 ATP molecules to get this reaction going. And that is going to produce 2 3-carbon intermediates. The 3-carbon intermediates are then going to be oxidized. And what happens to cause that is we have a molecule called NAD+, and what it's going to do is actually remove electrons from these molecules here to create NADH. Okay, that's going to actually happen twice to produce 2 of those. Additionally, we're going to get the production of 4 ATP, and our end product of glycolysis is 2 3-carbon molecules called pyruvate or pyruvic acid. So those are your steps of glycolysis. Notice we did not have to use any specialized organelles to do this. This can happen right in the cytosol of a cell. Once that glucose has entered the cell, we can go ahead and proceed to convert it into pyruvate. So once again, we do have to put a little bit of ATP into this reaction to get it going. So we get, we put 2 ATP in, however we get 4 ATP out. So it's going to give us a net of 2 ATP. Over here we have an oxidation event in which NAD+ is removing electrons from these intermediates. Okay, it's kind of like the opposite of photosynthesis when we were reducing or adding electrons to make a high energy molecule. In this case we are oxidizing or getting those electrons back from. Okay, so that's going to produce 2 NADH molecules. And then we have an energy payoff where we do get to produce some ATP. I had mentioned that earlier. That's how we got the net of 2. So we invest some energy here, we get a payoff here, that's the net of 2. And then lastly we end up with 2 pyruvate molecules, which will proceed to the next step. Okay, so it's going to be 2 pyruvate. So in a nutshell, that's what you're getting out of glycolysis. Net 2 ATP, 2 NADH, and 2 pyruvates. Okay, again, remember, this can happen with or without oxygen. Extremely versatile process. Many organisms perform glycolysis. Does not require the mitochondrion to perform